any of this, do please ask. Sorry? Am I going to post this? Yes, I will post this. Yeah, that was the last thing Mr. Shippets gave me. That was some of the before he retired. He came into my room, he said, with your beard, you kind of remind me of the that's Macho Man Randy Savage. WWF wrestler from back in the days, here you go see him. So, and then he retired, and then we never saw him again, so I keep it. We go, recording it. So there's that, and then I want to get rid of that, and I want to get rid of that. No, I want to keep that. I want to get rid of that. There we go. So there's the answers to those questions. And like I said, I'll post all that later. Cool. So we were looking at scientific notation yesterday. I had you guys do a bunch of math with the scientific notation, and then right at the end of class, what I said I wanted you to do, the only thing I actually gave you for homework yesterday was this. I wanted you to estimate objects that went along with these particular scientific notation scales. So if you're thinking of something that's 10 to the 0 meters, what kinds of objects are within that range? 10 to the 0 is what? That's a meter. So what kind of objects exist in that realm of size? People. Yes, people are meters long, not tens of meters long. Absolutely. People would be a good example there. Let's go bigger. Kilometers. What kinds of objects are in the scale of kilometers? Yeah. A stadium. Okay, maybe a stadium. What else? Stadium, I mean, that's why I put a question mark next to it. A skyscraper? Like the world, are we talking like the world's tallest building? Okay, let's put the world's tallest. I don't know, we'll check. Again, all I'm asking for is estimated objects. Okay, what other, yeah, Connor? Sorry? Roads? Yeah, but you think of a road as an object we can actually roads are like infinitely long. You can just keep turning. It goes forever. Someone said a bridge. Like what kind of bridge? Which bridge? Which one? The Golden Gate Bridge? I don't know. Let's see. Let's check. Is the Golden Gate Bridge a kilometer long? Okay. Let's go bigger. Megameters. When we're talking about megameters, what are we talking about? Like now this is truly abstract here. We're talking about planets, you think? This is 10 to the 6 meters. You're just making an estimate. What do you think of when you think of objects that are that big? So you think of a moon. Is that what I'm hearing? Yeah. The moon, like our moon? Yeah. Planet Earth's moon, okay. Maybe? What else? What other kind of objects might be on that scale of the, like 10 to the 6, that's a million. Like we're talking about millions of meters long or thousands of kilometers long, yeah.
Maybe like a meteor or?
A meteor? I hope not. That's a big meteor. Okay, so just to put this into perspective, if you're making some of these estimates, we can make that conversion. So 10 to the 6 is 1 followed by 6 zeros. So that right there is a kilometer. So we're looking at like 1,000 kilometers. What kinds of objects might be 1,000 kilometers as a scale for their measurement? Like, okay, so Canada. I gave you almost all the prefixes on your formula sheet. Okay, bigger yet, let's go giga. So now we're looking at, we're going up from 10 to the 6 to 10 to the 9. That's 3 more zeros. Now we're looking at 1,000,000 kilometers. The sun? Like the distance to the sun?
No,
Like the sun itself? The which? The what of the sun? Oh, the diameter of the sun. Okay. If you, I mean, you don't have to agree with Manuel. These are just estimates. If you have something else, yeah.
Stars in general can be measured by gigameters.
Stars in general. So there are much larger stars than our sun. Absolutely. Okay, let's go smaller. Centimeters. Kinds of objects exist in the centimeter range. Like the width of a pencil or the length of a like a pencil. When you say a fingernail, what do you mean by fingernail? Like the width?
The length of your fingernail.
Like the length of your fingernail? Typically, the width of your average thumb is like 2.5 centimeters. Just more perspective there. How about millimeters? What exists in the millimeter range?
The width of a coin.
The width of a coin. Anything else? Yeah. A wood chip. Depends on the size of wood chip, I guess. You could get wood chips in the centimeter range too, I guess. Micrometers. Let's get smaller now. So like the width of a hair?
Yeah,
Is that what you mean? Okay. We're going to check these all in a second. Okay, what else? Angelina, is that a hand?
No.
Oh, that's not a hand? What kind of microorganism? Yeah, well, give me an example. Fungi? I mean, yeah, microorganism is in the name, but different microorganisms have different sizes. So, like what? Sorry? Bruno Mars. Like, oh, the coronavirus. That makes more sense. Let's check out the coronavirus. The coronavirus is a microorganism. These micrometers are pretty small. Get rid of the sound on that for a sec. Okay, nanometers. What exists in the world of the nanometer? Yeah?
I don't remember where. I think it's somewhere in Southeast Asia that, like, the world's thinnest wire.
The world's thinnest wire.
We should get, like, a picture of that. It might be nice.
Well, let's put it on here. I feel like that's going to be real small. Yeah, Luis? Atoms. Perhaps? Yeah?
Like tardigrades and stuff.
How do I spell that? Tarda. Yeah, I got that. I got that far. G-R. Okay. Okay, so I wanted you just basically it was an exercise in thinking about scale. How good are you guys at thinking in some of these scales? I don't expect you to be very good. That's totally okay. Some of it depends on how well you're read, the kinds of things you watch, expose yourself to. So we're going to take a look at this. I'm going to record it. This thing is, it's called the, you see on your note where it says use the Scale of the Universe app to complete the following. The Scale of the Universe app no longer exists because it was in Flash and the internet killed Flash. So they created the Scale of the Universe 2. Let's go bigger before we go smaller. So this is the 1 meter. Where am I here? Where's my mouse? There we go. Oh, no, come back. Oh, this is going to be really slow, isn't it? I'm going to stop recording. Should hit unpause so that we can keep going. So here we go. So if I wanted to, in the basic algebra, we need anything beyond Math 10. We won't need anything beyond Math 10. The stuff we're going to do, I think, is fairly easy. Math 10, you did like factoring quadratics, right? Like you learned about the quadratic formula in grade 10? Is that where it first shows up? Yeah. That's the most complicated thing we'll need here. Yes, sir. Oh, that you're confirming what I was suggesting? Awesome. Love it. Okay? So let's just, but I always need to make sure the algebra is on the right page. Yeah, Connor?
Is there like a room or something? The turf field falls in
Whatever. There's custodial staff that'll fix it. Don't worry about it. Okay, so we want to solve this equation here for A. Let's zoom this thing in so it's easier to see. How do I do that? This should be relatively easy, not an earth-shattering result. Manuel, how do I solve F equals MA, an equation you're going to become familiar with for A? I want to isolate A by dividing by what? By dividing by M. Okay, cool. We want to divide by M because when there's nothing written M and A, between M and A, the implication there is that we are multiplying. When I divide, I want to divide by both sides, or divide by M on both sides. And so we're going to get that A equals F over M. Nice and easy. We like that. How about this one, number 2?
You're recording, right?
I am recording. Am I going too fast?
Nope. I just wanted to make sure.
Yeah, no, I'm recording again. Thanks for asking, though. And now I have to double check. Okay, let's keep going. Who wants to tackle number 2? Someone other than Manuel, because he'll do the whole course for you if you let him. But I don't want to let him, because you guys also have voices. How do I solve this equation here? V equals D divided by T, an equation that you should have seen for the first time in grade 9 math. Hoping. Maybe, yeah. I'm going to multiply both sides by T. What is that going to accomplish? It's going to isolate D. So it's going to cancel on this side, and I'm going to get D equals V times T. Cool, but I want to solve for T, so what do I have to do now? Sorry? Times by V? I'm already multiplying by V. Divide by V. So that's going to cancel there, and I'm going to get T equals D divided by V. This is good. Why couldn't I have just divided by D to start with? What would that have done? This is the cardinal sin of mathematics right here. I'm going to go up here. What if I had V equals D over T? And when I get T by itself, what does dividing by D actually do here? Who said that? James, is that you? Yeah, that leaves me with 1 over T. Because if I divide by D on both sides, the D's are going to cancel. I'm going to get V over D is equal to 1 over T, which I do not want. Okay, cool. We see how there's a difference here, yes? When we isolate for a variable, we want it to be alone, and we want it in the numerator. So we multiplied it up. I think it was Eric who multiplied it up to get it out of the denominator, and then we divided by V to get it alone. How about number 3? What do I got to do for that? How do I do that? Yeah, we're going to divide both sides by M. Okay, cool. So that's going to give me E over M equals C squared. And I'm squaring, so I want to undo the squaring. You said square root. That's the right thing to do. So that's going to cancel there, and I'm going to get C equals the square root of E over M. Cool. Number 4, I want to solve for this thing. Solve for D in this equation that will maybe one day make sense to us. Is it, though? Yes, Manuel? It kind of does. There's a bunch of squareds. We want to bring u squared to the other side. That seems like a good first step. How do I do that? Okay, so we're going to take away u squared from both sides. And that's going to leave me with v squared minus u squared equals 2ad. Because u squared minus u squared is 0, so when I'm adding 0, nothing, it's gone. Yeah, we can divide by 2a because all of this is just multiplied together. We're going to divide here by 2a on both sides. And that's going to leave me with d equals v squared minus u squared all over 2a. Cool, we like that. Hey, mister, yeah?
Correct me if I'm wrong, but that's something to do with the calculation of like the force of the gravitation force.
We'll get there.
Or the distance of time.
Maybe, sort of, we'll get there. This is arguably easier. I'm expecting you guys to gravitate a little bit more to this. What if I, instead of solving for a variable, I actually give you values to shove in there? I want to solve for d, given that v equals 36 meters per second and t equals 8 seconds. How do I go about doing something like that? Plug it in. Okay, well, let's plug it in. V is 36, so I'm going to get 36 equals d over 8. Now what? Yeah, Connor?
Yeah, okay, but you just say 36 8 times, right?
I don't know. It says 36 equals d over 8. Angelina, I see that hand. I'm going to, because I'm dividing by 8 here, I want to undo that, get d by itself. I'm going to multiply both sides by 8. It's very similar to what we did over here. So we're going to get d equals, well, 36 times 8. Well, that's 72 times 4, which is 144 times 2. Is that 288?
Yeah.
And what should the units on that thing be? I had 36 was meters per second, and I multiplied it by seconds. So if I have meters per second times seconds, I have seconds in the numerator and seconds in the denominator, which means the seconds are going to cancel and I'll be left with meters. You can cancel out units just like you cancel out numbers when you're multiplying and dividing. That's how we build these units, is by multiplying and dividing them around. In this next one here, I want to solve for m given that f equals ma. I got f equals 150 newtons, or 150 n, and I got a equals 2.50. That's meters per second squared. So I'm going to do what you guys suggested before. We're going to fill this thing in. I'm going to get 150 newtons is equal to m, and I'm going to throw that in brackets, 2.5 meters per second squared. How do I get m by itself? This m, the variable, not this m, the unit. I'm going to divide by 2.5 meters per second squared on both sides. Cool. It's going to cancel there. Leaving me with what? It's 150 divided by 2.5. 60? And what are the units on that thing? Take a look at what's going on here. I've divided the 150 over 2.5, I got 60. Now what's happening here? I've got n divided by m per s squared. How do I deal with this?
reapply it, so, per second squared.
What do you mean?
You have to cancel it out somewhere, so you'd have to,
Hmm.
you would have to apply it to 360.
No, the numbers have been dealt with. It's just this piece that I want to deal with now. It's very similar to what we would have done over here. I mean, we're just manipulating letters. So let's do some math with letters. I have n divided by m divided by s squared. What do I do when I divide by a fraction? I saw this. What does that mean? I do what with the reciprocal? I multiply by the reciprocal. So this is going to be n times s squared over m. And those are going to be the units on this. Well, isn't that interesting? M typically represents, what that letter typically represents what concept? Mass, which we also measure in kilograms. So kilograms then must be equal to newtons times seconds squared per meter, which is weird. That's weird. Okay, here's what you're going to do. I want you to do you are going to get some homework from me tonight. We'll do the trig tomorrow. Make sure your trig game is up to par. I want you guys to do this. There's 4 questions on this side. And there's 1 question on the back here. That is what I'd like you to try and get done tonight. We'll talk about it tomorrow. Tomorrow we'll refresh trig. Oh, guys, I'm not done talking. Don't leave yet. We'll refresh trig tomorrow, and I'll introduce to you guys some sig figs if we have time. Now get out of here. See you later. That's your homework.
4 questions on the other page.
If you didn't finish the other page, then yeah, you got to go get that done. You mean this page here? Connor? If you finish the unit conversions, then all you got to do is the algebra questions there, and you're fine. There we go. See you later, Tristan.